Assalamualaikum warahmatullahi wabarakatuh and a very good morning. Today I want to review on the topic of how to differentiate different types of design and also how to identify fixed or random effect model. Based on my observation of your result of the test 1, I noticed many of you still unable to identify whether the design is completely random design or block design or repeated measure design. And also I noticed that you do not know how to identify whether it is fixed or random effect model. So today I want to review again how to identify these types of design. Okay. Now, I want to highlight here, once you get the problem, you should know how to identify whether it is a random effect or fixed effect model, whether it is a completely randomized design, block design, or Latin square design, or many other designs that we want to discuss later. First, you must know how to differentiate different types of design. So here I want to highlight that the major difference among different types of design lies on the design objective and different methods of randomization of the treatment to the experimental results. Now, first let me discuss the design objective. So if you have a problem, then you want to know what is your design objective. For completely randomized design, the design objective is to analyze the effect of one factor on the response variable. And there is no extraneous factor that will affect the experimental results. Now, for completely randomized design, the main objective is still the same. That is, we want to analyze the effect of one factor on the response variable. However, for the completely randomized design, there is one extraneous factor that will affect the experimental results. Now, for Latin square design, the main objective still the same like the completely randomized design and block design. What we want to do is to analyze the effect of one factor on the response variable, but there are two extraneous factors that will affect the experimental results. Now, once you have already choose the correct design, then you want to know whether it is fixed or random effect model. Okay. Well, first you have to identify whether it is fixed effect or random effect model. For the fixed effect model, I already discussed this in class, that the T treatment, how many treatment that you want to compare? Let's say I want to compare T treatment. This T treatment could have been specifically chosen by the researcher. We specifically chosen. Let's say I want to study the effect of 4 types of detergent on the whiteness reading of white cotton cloth. So specifically I choose 4. 4 types of detergent. 4 types of detergent. Then for the fixed effect model, you have to know that what you want to test, you want to test hypothesis about the treatment mean. The treatment mean. And the conclusion can only be applied to the treatment considered in the analysis. Let us refer to the same example. I want to analyze the effect of 4 types of fertilizer, 4 types of detergent on the whiteness reading of white cotton cloth. So meaning that the conclusion can be applied only on these 4 types of detergent. And here, point number 3, the conclusion cannot be extended or cannot be generalized to similar treatment that were not explicitly considered in the analysis. So here, let's say there are many detergents in the market. There are 100 detergents in the market. When I study only 4, let's say A, B, C, D detergent, the conclusion cannot be extended or cannot be generalized to all 100 detergent in the market. Alright? And in this fixed effect model, I want to estimate the model parameters, that is mu, tau, and sigma squared. Okay? So, if you choose the fixed effect model, then how are you going to state the hypothesis? Alright? Let me show you again this, how to state the hypothesis. So for this, for fixed effect model, the hypothesis should be stated in this fashion, where you base on the tau. Tau, or you can make use of the mu. If you use mu, meaning that mu1 equal to mu2 equal to ... mu t. And h1, not all mu's are equal. Okay? That is for the fixed effect model. Now we look at for the random effect model. For the random effect model, it's different from the fixed effect. Where for the random effect model, you first, select at random T treatment. You select at random T treatment from a larger population of treatment. You should select T treatment from a larger population of treatment. Select at random. Okay. And for the conclusion, for this, conclusion can be extended or generalized to all treatments in the population, whether they are explicitly considered or not in the analysis. Just like what I already mentioned last time, where we refer to the detergent data example. Let's say now you want to, a researcher want to test whether there is a differences in the whiteness reading for all detergent in the market, whether it is considered in the analysis or not. For this, if you want to generalize to all population of treatment, first you have to remember this is very important. Firstly, you have to select. Have to select how many treatment at random from all population of treatment. Let's say you select 4 detergent from a larger population of detergent. Okay, this is very important. If you read a problem, then you have to first identify what is the treatment, then select. If in the question mentioned you select T treatment at random, then this will be random effect model. Okay. And for this model, tau, that is the treatment effect, are a random variable because you select treatment at random. Then this tau, which represent the treatment, is a random variable. And it is useless to investigate tau because it's a random variable. So we do not have to investigate tau. Instead, we want to test hypothesis about the variability of tau. And try to estimate this variability. So it's very important for random effect. We want to test the variability of tau, the variant for tau. So the way how you state the hypothesis will be different from model for the fixed effect model. Okay, so now you look at this. Look at how I state the hypothesis for the random effect model. Now look at this. Now you look at how I state the hypothesis. I do not state the hypothesis in terms of tau or in terms of mu, but sigma squared. Sigma squared tau equal to 0 and sigma squared tau greater than 0. I test the variability denoted as sigma, not mu. Okay. So I hope by now you should know how to differentiate between fixed effect and random effect model. Now, before I look at this example, let's again look at how to differentiate different types of design. To differentiate different types of design, number one, I already mentioned that we look at the design objective. The design objective will be different. And then look for the second point. This is also different from different types of design. So the second point here is different methods of randomization or different technique of randomization of the treatment to the experimental units. Yeah. So, see, if you look at problem of complete randomized design, block design, and Latin square design, you will be aware that the technique of randomization of the treatment to the experimental units will be different. Okay, so this will differentiate different types of design. Point number one, design objective, and point number two, different techniques of randomization of the treatment to the experimental units. Okay, now, so you have to remember this. Yeah? For completely randomized design, you have to recall what I explained to you last time regarding how to do randomization for the completely randomized design. Yeah? The treatment, for CRB, the treatment are assigned at random to all of the experimental units. Yeah? And then for the block design, the treatments are assigned at random to the experimental unit within each block, independently with other block. You do it separately. For each block, independently with other block. Second block, third block, and so on. You have to do it separately. But for the completely randomized design, you do at one time, meaning that the treatments are assigned at random to all of the experimental units. Okay, now we look at an example. Okay, now this example, I took this example from the test 1 result. I took this example from question number 2, test 1. Where here the problem is a computer company wishes to analyze the effect of 4 models of programmable calculator on the length of time required to solve a particular problem. So here, if you look at this problem, this company want to analyze the effect of only 4 models of calculators. 4 models of calculators that you want to see the effect on the length of time required to solve a particular problem. Meaning that here, if you read more, you can see that the researcher only want to make conclusion based on these 4 model of calculators. So meaning that he don't want to generalize to all models of calculators, even though it is not considered in the analysis. So if only if we want to conclude only on this 4 model, the 4 models of calculators is the treatment, then this will be the fixed effect model. Okay, and then look, once you look, you know that this is the treatment. The treatment is the 4 models of calculators. Then you know T equal to 4. Then you say first you think that this is the fixed effect, and then you look further the clues whether it is confirmed that this is a fixed effect model. Then you look in this this problem whether you can see or not the word that the model of calculators are selected at random. So you do not see this, right? You read more, you do not see that. You do not see that the researchers select 4 models calculators at random. So here, it confirms that this problem is the fixed effect model. If let's say here somewhere in this in this problem, I mentioned that the researcher select 4 models of programmable calculator at random. So meaning that this is random effect model because you want to generalize the conclusion to all population of treatment. Then you want to identify whether this is completely randomized design or completely randomized block design. Okay, so here you know already what is the treatment. Then you try to find out is there any extraneous factor that will impact the experimental result? Then you look at this. Who is going to use this calculator? Engineer. Yeah? Engineer will use this calculator. Yeah? So first, before you finish reading this, before you decide whether this is a block effect or complete randomized design or block design, you first need to know whether there is extraneous factor that will affect the experimental result. Yeah? So here you look at the engineer here. Yeah? The engineer will be the experimental units. Then you say, this engineer might have, if you use different engineers, then it might affect the experimental result. Yeah? Then you read more and say, the engineers, here look like the engineers here, you use only 3 engineers. Yeah? You use only 3 engineers. If you use T equal to 4, yeah, engineer 3, block 3 multiplied by 4, if you use 12 engineers, yeah, then this might be completely randomized design or block design. Yeah? But since here you use only 3 engineers, meaning that the engineers might be a random sample of block. Yeah? So look, now you use only 3 engineers who were proficient in the use of these calculators were randomly selected. So what is randomly selected is the block, not the treatment. Yeah? So the engineers were randomly selected. And they were asked to work out a problem by using these 4 different calculator models. Yeah? Meaning that each of the engineer have to use these 4 models of calculator. Yeah? Each of them using all of the treatment. So in this situation, I already mentioned that if each of the block receive all of the treatment at different points of time, then this will be repeated measure design. Yeah? See here, I don't have to mention that the engineers use the different the 4 models of calculator at different points of time. Yeah, I do not mention that. Yeah, so since each of the block receive all of the treatment at different points of time, then this will be repeated measure design. A special case for completely randomized design when block is random. Yeah. Okay. What else? What else I want to explain here? Yeah. Let's say for this kind of problem, this is repeated measure design. Yeah. Let's say how I'm going to change this problem if this is completely randomized block design. Yeah. If completely randomized block design, then I will say that 12 engineers. 12 engineers are grouped according to their age. Let's say. So meaning that now I will have 3 age group. 3 age group of engineers. Or perhaps I want to say that the engineers are grouped according to their experience. So this could be another variable that we call it extraneous factors, that the age group of engineers and the experience of the engineers as the block. Okay. So then if I have age group of engineers or experience of the engineers, then I have 3 blocks where I will mention that the models of calculators are assigned. The 4 models of calculators are assigned at random to each age group independently with other groups. Okay. Now let's say now how I want to make this problem as the completely randomized design. So if this problem is completely randomized design, meaning that there is no extraneous factor. If no extraneous factor, meaning that the engineers have the same characteristic. I do not mention that the engineers have the same characteristic, have same experience or what. But if this is the situation, then how I am going to assign the treatment to the experimental units? So I will say that the 4 models of calculators are randomly assigned to 12 engineers at random. Yeah? So you see that, yeah? how I write the problem in such a way that it is suitable for completely randomized design, for completely randomized block design, and also for the repeated measure design. Yeah? So I hope by now you should know how to differentiate between different types of design, and also how to identify whether this is a fixed effect or random effect, so that you will make a successful action of selecting the correct design to analyze your data. Okay, I think that's all for today. Thank you.